So hello everyone. It's really nice having you today. We're really excited for today's session. I'll just start with some few slides. Let me share my screen. Can you see my screen?
Yes.
Yes.
Yeah. So just as usual, we would like to thank our supporters and trainers for making this training possible. So we'd like to thank ORFG for all the funding, all the infrastructure that we needed for this training, and our trainers, of course, who volunteered kindly from their busy times to join us and help us out. And would like again to remind you all of the code of conduct that we'd like to adhere by, which is to embrace our diversity, promote constructive communication, and foster collaboration and sharing, and maintain professionalism in this agreement. And again, if there is any breach of this code of conduct, you might reach us out via our email or use the incident report form, which is already in your Google Drive. So today, let's meet our trainers. And we're so excited that today we have two very wonderful trainers from the Reproducibility for Everyone. I would really appreciate if we all mute our mics. Thank you. So our trainers today are from the Reproducibility for Everyone initiative, which has long been working on reproducibility of research and reproducibility of the research process from the beginning. So today we have Susann R, and we have Nele, Nele Haelterman. And just to give you a brief introduction to Susann. Susann is a lecturer and a plant biologist from TU Dresden, Germany, and she has long been passionate about open science and reproducibility in research. And she's been working for a long time in reproducibility for everyone. And she's also passionate about passing on this knowledge to her students, which is really good because this is what we need. We need the newer generations to be equipped with this knowledge. And then we have Nele, who is an assistant professor in molecular and human genetics in Baylor College in the USA. And Nele also is very passionate about communication and advocacy, and she runs a blog for early career scientists, which is called ECR Live, which I encourage you all to join and check out. And she's also been part of the Reproducibility for Everyone initiative for a very long time. And both Nele and Susann would love for you to connect with them via LinkedIn. So please let's welcome Susann and Nele, and let's hope for a really productive and engaging session today. Okay, so now I'll give it to Susann. Susann or Nele? I don't know who would prefer to start.
Yes, thank you.
Yeah.
I'm going to start, but we always introduce ourselves shortly. We do this with a slide as well. So I'm going to introduce myself first because I'm starting the session, and then Nele is going to also make another quick introduction because this is how we run our sessions.
Yeah.
I just posted the chat in the chat. I posted the link to the Etherpad. The Etherpad is our communication tool for the session. So I'm just sharing my screen here. And so what you will see then is in the shared notes document, this is the Etherpad that I just linked to. And then you can go there and you also have the link for the slide deck. All right, so Lamis has already introduced myself. Thanks a lot. So I'm a plant biologist and a lecturer at TU Dresden in Germany. It's really in the east of Germany, and you can, if you want, you can follow me by on LinkedIn. And so I just want to introduce reproducibility for everyone. So we are a community of scientists in academia and industry. We want to improve reproducibility of science. And so we have members all over the world in our community. We organize over a Slack channel, and we help the members in our community helped to develop these slides that you're going to see today. They help with hosting workshops, applying for funding and all that. So it's a group community. It's an effort of really a lot of people. And so we have developed this open access workshop, which you can use yourself also. So you could also take our materials and do these kind of things at a journal club or seminar institute. So they all have a CC BY license, as long as you also indicate where you got these slides from. You feel free to use them. If you want to join us as a community, you can reach out to us, or you can click the link reproforeveryone.org join, and we always welcome new members. So we were very fortunate to have good funding in the past. So we had a big grant from the John Zuckerberg Initiative that enabled us to have a community manager. We currently are applying to different funding sources. So right now, theoretically, we are not funded by anyone, but we'd like to thank our previous sponsors that we got. So if you want to read more about our initiative, we have written a paper about what we did. So most of us met over the eLife community. Actually, we were eLife ambassadors, Nele and me, and also Nafisa, we are kind of, as the three of us are running the initiative a little, we are currently guiding that. So we are a women empowered team, a guidance team right now, and we get so much done, you know. So I'm very proud of us. So Nele and Nafisa are in the US, I'm in Europe, I'm in Germany. And so if you want to know more about the initiative, I linked the paper here. There's a preprint to that, and then that explains a little what we do, and there are some resources in that. We have a code of conduct as well. Of course, as always, please be respectful, give everyone a chance to contribute, use inclusive language, be appreciative and accommodate differences, and lead by example. And we don't want anyone to repeatedly interrupt or disrupt others, use sexual language or imagery, give unwelcome attention, bully, discriminate, or harass, or make fun of personal appearances or choices. If any of that is an experience you have during one of our trainings, please contact us. You can report by email, or you can also send a message to Nele, and then we were going to work on that. If people do not comply with the code of conduct, we have the freedom to remove them or to mute these participants. So it's, yeah, we very much care for diversity and for giving people a space to be welcome, and we try to be as inclusive as possible whenever we can. If we make mistakes, please tell us. So during this little webinar that we have together, we use the Etherpad for communication. So please do not use the Zoom chat for questions, because that's going to then be borrowed under other maybe Zoom messages. So please put everything in the Etherpad, and we will circle back to these questions later on. All right, so today we talk about reproducibility. And the objectives, the learning objectives we have for you today are, first of all, hopefully to be able to define and understand the importance of reproducibility, to be able to distinguish between reproducibility and replicability, and to learn about factors affecting reproducibility. So we are starting on a kind of meta level with very basic concepts, and then in the next session, we're going to talk a little bit about other stuff. And in level 2, we will go more into depth about all of these kind of things and more practical tools that you can employ. So why does reproducibility matter to you? I would love to know from everyone being with us today. I would love to know a little bit more about you, if you ever had issues with anything that came about reproducibility. And I just see that I need to change my screen because I don't have the right.
Emmanuel, maybe you could.
Yeah, Susan, I could launch the poll for you.
Or maybe you can start the poll. That would be really
Yeah.
great because
Yeah.
my screen is not really enabling me right now to access that. So if you could start the poll, that would be really wonderful. Thanks a lot.
Yeah.
So we want to know, have you ever had problems reproducing your own or someone else's research? So please click on whatever you feel is something that you have experienced. Okay, so I see we are finished. So everyone, no, we're not.
Just
Almost.
two more. Yeah.
Yes, 2 more. So there was supposed to be also an option, I never had issues. I don't know. That option got, I don't know why it didn't make it. Sorry for that.
We do have a raised hand. Daniel raised his hand. Is there something you'd like to say, Daniel?
My apologies, I may not be able to contribute simply because I'm at an eating place and the connection is very poor.
No problem.
Worries.
That's what I wanted to communicate.
No worries.
I'm not in my office. Yeah.
No worries about that. No worries.
So I was not able to take part in the poll.
Okay, no problem. No problem. You can
No
also go
problem.
to the Etherpad if that works, and you can answer it there too.
Yeah. So I'm going to
Yeah, okay. All right.
now. And then we're going to share that. So I hope you see the sharing. So a lot of people said, or the majority said, there were issues with someone else's study that they were not able to reproduce, or their own research and someone else's. So this is something we always ask our audience, usually before we do our workshops, if they ever had any issues. And of course, people who come to a workshop on reproducibility, when they come there voluntarily, they will be biased because they will have issues with that. And of course, we would kind of expect that there's something going on here, right? So, but yeah, this is just be aware that this is a very common thing actually that we see with all of the people visiting our workshops. And so if we put that a little bit more into the professional sphere, so there was a study about that that was published in 2016, where 1,500 scientists were asked about reproducibility. And so when they were asked, have you ever failed to reproduce an experiment, you can see here in these different areas of research. In chemistry, more than 80% said they had issues to reproduce an experiment of someone else. And more than 60% said they had issues reproducing some of their own results. So I'm in biology. So here the situation is very similar. People in medicine also, half of them, or a bit more than half, answered honestly that they had issues reproducing results. So this is something that's not necessarily field specific. It really occurs in all different kind of scientific fields. And here is another overview where people were asked, how reproducible do you think your research field is? So how much of the published work in your field is reproducible? And you see here, physicists and chemists were most confident in the literature. So if we want to read that, this kind of area here is 1/4 of the respondents. And you see here, this is, so we have this kind of huge response here. When we go here to the scale. So something like they say, okay, 70% or more of the research in my field is reproducible. That's what people said. Although earlier the chemists said, I'm not able to reproduce a lot of findings. So there's a little bit of a tricky and slippery slope here. But this is, what do you feel? What do you think is reproducible? And it really depends, of course, on who you ask. If you ask someone who's very experienced in the field, or maybe a person who's a young scientist early in their careers, maybe they didn't have issues because they just did not try to reproduce a lot of stuff. Regardless, reproducibility is an issue in all scientific fields right now, and the lack of reproducibility. And so there was an estimate that in the US alone, over $1 billion of US dollars were lost each year due to irreproducible studies, because people have to do stuff again and again, and they are not able to come to the same conclusions and findings. So to drive the point home a little bit here, we have a lot of research right now that is published. So the amount of papers is crushing. No one is really able, even for their own field, to stay on top of the literature and to read everything that was published. In medicine, I think the situation is especially dire because there's like a new cancer treatment and a new treatment for this and that, and then this lab did this. And so it's really hard sometimes to find mistakes in peer-reviewed literature, but even if mistakes are found in the literature, it's really hard to fix them. Because then if you find something, it's not reproducible, and other groups also find, okay, this finding cannot be reproduced, then you would have to contact the journal, and you would ask for what the authors are saying. And then if everything's like true and the authors actually for some reason did make a mistake, you would have to retract the paper or post a correction. And these kind of things rarely happen, actually, not at the amount that they should happen. So the peer-reviewed literature is, once it's published, it's really hard to fix if anything was wrong. And so there was a big attempt to replicate findings from the top cancer studies, and that actually failed. So half of these top cancer studies were actually not reproducible. So that's very worrying, right? Because we treat people with the drugs we think that are working due to the science. And then if this is not true, then, you know, what do we end up with? So my field is biology. I come from ecology as a background, and there was a huge scandal of one person, a spider researcher, who fabricated data and committed fraud. So these are also sometimes examples of people where there's like specific people who actually do fraud, who do it intentionally. Most of the time, though, we always kind of put the grace to that and say, okay, we think there's a lot of mistakes just probably there, and this is why stuff is not reproducible. So today we're going to look at what does reproducibility mean, because we have to talk about definitions, of course, what are different modes of that? Is that all it matters? And then for today and next time, we're going to explore a little bit the reproducibility tool shed with you and make it more practical in level 2. So what does reproducibility mean? The definition of reproducible research is the one that we go by and the Turing Way goes by from Barber and Schloss 2018, which says that the authors of a manuscript provide all of the necessary data and the computer codes to run the analysis again, recreating the results. So you as a researcher, if you do a study and you come up with your results, if you reanalyze your own data with the same method, you should come to the same results. A replication is a study that arrives at the same scientific findings as another study, while they were collecting new data and completing new analysis. So a replication attempt is usually someone else in another laboratory, in another work group, tries to find the same. They try to replicate a study. There is this matrix of different terminology of reproducibility. So what we ultimately want for our own research is having the same data, using the same methods, coming to the same conclusions. So reproducibility at its very kind of minimum basic, which is hard to do still, right? We talked about replicability. So here you have a different data set that you use. You collect new data, different data. Then there's using the same data, but using a different method that would be called robustness. And then if you have a big finding and people are able to collect new data and analyze the data a little bit differently, use a different method to analyze and still come to the same major finding, then that would be generalizability, what we want, like gravity. If I let an apple drop here in Germany, it's going to fall to the ground. And if you, Nele, in the US, let an apple drop, it's also going to fall to the ground. And if you do that in Nigeria or in Somalia or somewhere else, it's going to be hopefully similar. It should be, because we're not on the moon, right? So gravity is a very generalizable rule over the Earth, right? All right, is reproducibility all that matters? No, of course not. So, of course, when we are in science, we kind of expect people, scientists, researchers, to work with scientific rigor. So first of all, we always assume that they are honest, they have intellectual honesty, so that you are trained as a researcher to do the kind of work you are currently doing. And you do that because you have also a good understanding of how science is working, how to design experiments. So we have to have a good understanding of probability and statistics to do the correct analysis. You have to design your experiments or your research so it's logic. So maybe you do hypothesis-driven research. So these hypotheses have to be designed in a way that it makes sense with the previous knowledge we have. Experimental redundancy is key for really specifically, as an example, again, hypothesis testing. Okay, so I tested this one with that kind of experimental design. If I tweak this, it should still have the same kind of findings. And then error analysis is very important as well. So we expect people to have to work with scientific rigor. But of course, we are all in different paths of our careers. We have different trainings. We have different capacities of what we can do. And so we always encourage people who try to work reproducible that every little bit helps. So if you're here and you take one or two things for your research away, where you say, okay, maybe I could improve that to be a bit more reproducible with my research, that's a good starting point. So it's kind of a lifelong journey. What you can always do is transparent and open science. So that is something, no matter where in your career you are, if you are very late in your career already, if you are in the middle or at the beginning, or you probably don't know where you're going to end up. So being transparent with your reporting, being transparent with your reporting, and doing open science, publishing as open as you can is always a good thing. So everyone starts somewhere, right? Now, there are different factors that decrease reproducibility, and we group them in these kind of 4 broad categories. Let's just go over a few of them. So there can be technical factors that hinder reproducibility, natural variability as an example. So I'm a plant biologist, I work with plants, and I have to raise plants a couple of times, do a lot of experiments with the same treatments to be able to actually see if the treatment that I do to the plants gives what result it actually gives. So each plant is different. The year of the season depends here on how the plants are behaving, just as an example. So there's some natural variability there. And I'm pretty sure if you're working with biological systems, you have experienced that as well. It could be you have bad reagents, or maybe there's some other technical issue there that hinders reproducibility. Then we have human factors. So we have confirmation bias. So here, for example, you have you kind of have this idea that this is how it's going to work. And so even maybe if your students are coming and they have a different result, but you still focus on that, you're totally convinced this is how it's going to work, you probably have confirmation bias pretty strongly, and then that's something you should work on, basically. Other human factors like poor record keeping, we can work on. We can work on our own confirmation bias. We can work on how we share our materials, our reagents, methods, data, and code. And if the sharing is poor, people are not detailed enough with that, with sharing of data and code, that also leads to irreproducibility. Then there can be issues with study design and statistics. Maybe someone misunderstands a statistical concept, and so the analysis is flawed. Then we have this kind of a field here of fraud. So p-hacking is when you repeat a measurement or an analysis so often that at some point the magical p-value of 0.05 will be reached anyway, because you just have done it 2,000 times. Harking is another part which is fraud. Harking means hypothesizing after the results are known. So someone does hypothesis-driven research, they design the experiment, they have a result, and then they say, well, that result, that's not what I expected, so I'm just going to tweak the hypothesis now, and then publish it as, that's the hypothesis I wanted to test, and this is the result. That would be bad science, bad scientific practice. And there's selective reporting, a bias for reporting only the positive results, only the tremendous big results. So we consider most of these things as mistakes or lack of training. But we are not, of course, working in an ideal world. So as scientists, you know, there's a lot of competition for money, for resources, for people, for being in the right spot to do your research. So hyper competition and pressure, of course, also make people to maybe be a bit sloppy with their science, or to publish something really quickly, even if it's not finished yet, because the incentives are not necessarily to do it right and take your time and do it like perfectly, but rather to do it very quickly. And so these kind of incentives and this way that science is working, that's something, if we are later in our career, or if we are sitting in the right committees, that's something we can work on. But globally, that's another issue, of course. Yeah, and then there are paywalls, right, who stop you from actually accessing the science, specifically if it's papers published in very expensive journals. So you saw all these kind of factors. Maybe you took notes on some of them, where like record keeping could be one you could tackle on. We're going to talk a little bit about this today. But I want you to kind of try to reflect a little on where's your biggest potential for growth. Because that could be something that leads you forward. And when we ask the community, so when we do these workshops, what are major improvements that you can think could lead to more reproducibility? This is a snapshot of what people said. So you see here we had 82 responses, and many people lamented that methods should be written better and more detailed. So that's a huge thing. Again, poor record keeping, poor sharing would that be. Open data and metadata would really be helpful. Less pressure to publish, fewer incentives to be first, better code sharing. So these are the kind of things people said, this would really help for better reproducibility. So to quickly come back to the beginning, so reproducibility, if you want to do it well, it's really a journey. Everyone starts somewhere. No one of us is perfect. And every little bit helps. So if then we go through a few specific samples. So Nele is going to walk you through a few things you could do. And I just want to preface that by saying, if you start doing science reproducibly, or you try to kind of focus on that a little bit, it's not only good for you, but it will save you really time on the long term, and is also good for other scientists.
All right, my turn. So yeah, Susie gave a great introduction into you know, sort of the framework of the reproducible framework, let's say, and what it means and why it actually matters. My name is Nele. Thank you, Lamis, for introducing me. It's fine. I'm originally from Belgium, and I moved to Baylor College of Medicine to do my PhD, and now I'm here as an assistant professor. But all throughout, I've struggled with, you know, keeping my experiments reproducible, not just mine, but others too. And so this initiative has really helped me grow. And like Susie said, you know, you start somewhere. I'm still changing how I do my science quite regularly when I find new things. You just start with one step and you sort of go along the way, integrating others. So we're going to talk about data management now, which is really an easy thing to change. It does take effort, but mostly you got to stay consistent with it, and it really makes a huge difference. So I think I'll ask, but I think many of us will be familiar with these kind of thoughts where you know that you did something in the past, and you know that you saved it somewhere. Just can't remember where or what you called it, because we tend to repeat our experiments, right? You're optimizing it to make sure that everything runs smoothly, that you can get to a good result that you can trust. Once you're there, you're collecting data and you're repeating the experiment. So there will be many different file names, and so it's going to be, at some point, if you don't have a good system in place and you just, call it new, okay, new, but then this is the final of my first version, then actually, no, I still have to make an edit. So you kind of tend to change your file name, but without a good system, it's very easy to lose what it is that you actually need. So we're gonna give you some tips and tricks that you can try to implement to actually avoid that problem. But a lot of that comes or circles around making a plan and really thinking through what you are doing before you start. There are some tools that can help you with that. The DMP tool is one of them, so you feel free to go try that out. But again, I'll emphasize that you don't have to do everything at once. It's just impossible. So look at, the tips that we're offering both today and next week, and see what you would like to try first, and sort of build on it from there. Next slide, please. Okay, so before you actually start, it's really important to think about the data that you'll produce as part of your experiments. And once you have an idea, sometimes that's hard, because when you're optimizing your technologies or your experiments, you don't really know what the final data is going to look like yet. But still, you'll have an idea of what organism you'll be working with, what the experimental design of your study looks like. And so that's when you have to start thinking about how you're going to store all of that data. What kind of standards are you going to implement in storing that data or in collecting it? And how are you actually going to protect this data, whether it's patient sensitive data or whether it's less sensitive? You will still need different ways to actually make sure you can store it somewhere safely in the long term. It's very important to also think about who has the responsibility for taking care of all of those activities that we talked about before. So is it just going to be you who will be the backup should you be out for some time? And when are you going to do all of these steps? So you'll be creating data. You're going to be processing it, so you can see sort of the data life cycle there, all of the different elements that or steps that take place for data. And so all of those can be done by different people or by the same person, but you have to have a clear plan in place, and have a plan to transfer that information. Because if you decide that you're going to change positions or you change institutions or labs, someone else will come in and will take over this project. And if they come in, let's say at the analysis phase, and they have no idea of how you actually organize your data, I can tell you it is incredibly painful and sometimes even impossible to pick that up. So try to think on beforehand how you're going to structure all of this, so that someone else, even if it's you, sometimes you forget how you did something, 2 years ago or even a few months ago. But structure it in a way so that someone else can take over and still understand. Next slide, please. So part of that is actually thinking through the metadata of your experiment, and metadata really is sort of the data about your data. And so what that means, it's an element, it's a piece of information that talks about at least one aspect of your data. And that sounds a little bit abstract, but I'll give you some examples in the next slide. And so what it really comes down to is that you have to think ahead when you're planning out your experiment. Try to think about which parameters of this experiment are important for you in the future to understand how you did this experiment from the beginning all the way to the end. I mean, for me, for instance, I work with mice. Which strain of mice did I use? What age were they? At what age did I do surgery on them if I had to do surgery? When did I collect them? All of those things, you know, you can be, you know, in sort of a pipeline where you're repeating things, everything stays the same all the time. But then you get one piece of information and you say, oh, I should collect them 3 months after, not 2 months after. So you make one small change. And if you didn't record that along the way, sometimes it's hard to then a year later say, oh, this first data set, was that collected 2 months after, or was that 3 months after? So you have to sort of think through your plan. You know, many of these things we collect in our lab notebook, but if you have a structured way to record them, for instance, on a spreadsheet, it actually makes your life much easier down the road. And so this is, you know, sort of the packet that you send to the future you that contains all of the information about your experiments in a structured way. Next slide, please. So these are some of the examples of what should go into a metadata spreadsheet. The general information that I just mentioned, what species did you work with, if it has a gender, what was it, when was it born, when was it collected. It works very well for you to stay organized in a sense that you add a unique identifier for each subject so that you can't confuse, you know, don't call it cohort 1 mouse 1, for instance, because someone else may call their mouse 1, 2, and it's very easy to confuse samples in the freezer, for instance. Which samples were collected from the animal or from, you know, the organ, what was collected, when was it collected, how was it processed, how was it fixed, how was it stored, where was it stored, and then some of the experimental details as well, you know, which instrument was used. If you, for instance, if you take some pictures with the microscope, which microscope, what were the settings? Some of those you can get from the file name, so you may not need to record them, but it's important to sort of think through these steps of what would you need down the road to be able to do this again. And finally, where can you actually find the sample and the data? So those are things, even if you are already in the middle of your experiment, you can still, you know, try to start that spreadsheet and start populating it with where you're starting now, and go back and populate what you can before. This will help you, your future people who will work with this project, but also if you plan to upload your data to any repository, they will often ask for this kind of metadata to be to accompany your data set. So you'll make your future life a little bit easier if you try to plan ahead for that. Next slide, please. So I talked about the data now, but I also want to give you somewhat of a plan of how to actually store your data in folders, because that also gets very confusing very easily. And so here it helps to have a directory structure so that you can very easily go back and see what is where. So you can have, you know, for if you work on different projects, for each project you can have a main folder where you have subfolders where you can store the methods, the raw data, the files related to the analysis, whatever scripts you may have run, and whatever manuscript you might be writing about it. What I think is very helpful is to include what's at the bottom there, a README file or a link to your electronic lab notebook. I try to include, this is something I learned from this workshop. I try to include a README file in my main folders, or even for a spreadsheet, I try to have on the first page, I have a README tab where I just explain what you can find in the spreadsheet, how it's organized, and so to help sort of read the spreadsheet or the folder or the experiment. It doesn't take all that much time to write it down, but it really does make a big difference in the future. Next slide, please. So yeah, once you have this structure set up, then you can start populating it with the individual elements, and then it'll be later down the road. You see that in this case, for instance, for the raw data, there was another README file added just to explain what was collected. So this would be, for instance, part of the metadata that would probably be stored in that README file. Maybe you changed your analysis method, so it went from
Oh no,
I don't know where you went, Susie.
I broke it. Sorry, I'm
It's
sharing.
okay.
Do you want to share your screen or your co-host? Because then...
Yeah, hold on. Because now let's see, where were we?
I'm back. I can also share my screen again.
Yeah, it'll probably be faster because I didn't have it open here on my end.
Oh, wait a sec. I'm sorry.
Okay.
Instead of sharing my screen, I clicked on something. That was not intended.
It's okay. It's okay. So if you wanna read that blog post, you see that Susie just clicked on it. But
Yeah.
so for instance, if you change your analysis method along the way, sometimes it's hard to keep track of that. But here, once you have a nice and structured way set up, it's very easy to say, oh, that's right, all the experiments I did in these 2 years, or even in 2017 and the first half of 2018, they're all here. So it makes it easier to go back to things down the road. Next slide, please. Okay, so another very important thing to keep in mind is that you really do have to keep your raw data. I know that in the size of these files has changed dramatically over the last 10 years, and raw data can be really large, but it is really key to keep that and to actually make sure that you have backed it up, ideally 3 times in a synchronized way. It can seem very convincing to just keep your processed file, but if you need to change anything down the road and you didn't keep your raw data, then all of that is lost. So that is, my sales pitch for for just making sure that you think about, where do I actually have my raw data right now? Please don't keep it on your thumb drive or your USB stick, because you can misplace it, and a year of work can just be lost. Next slide, please. Okay, so the last thing that I'll talk about here is some tips on how to actually name your files. And so here again, I've been here many times where I'll call something, I'm done. I received input from everyone. This is my final document of, let's say, the final version of the manuscript. And then, someone else comes back with some feedback, and you still have some changes. So then it becomes final revision 2 or final version 2. And it sort of keeps changing. And so your file names can become very complicated very quickly. Next slide, please. And again, that makes it harder to find over time. So in general, there are a lot of different tips and tricks on how you could name your files. In general, you can really feel free to use the one that helps, that makes the most sense for you, as long as they are meaningful. So you can include a date. If you do include a date, it's better to follow the format that's described there, because that actually helps in storing, in ranking the names in your folder. You can have group identifiers. Mostly, again, like with that README file, if you document your decisions, it makes it much easier to find things later. And the most important thing is to stay consistent, and then go through version numbers. So this is my version 1, version 2, version 3. You can add the date to it if you want, but it'll make it much easier to find. So here you can see from least to most complex, a very long file name. This would be, for me, this would be way too long and too a bit too extreme, but you can see from the least general to the most specific, from the left to the right. So here you have your date, you have the name of the project, which number of experiment it was, what type of data it is, who was actually the person who collected this data set. and then what version of file this is. So you can sort of think through your data structure and think through what elements you would need. You know, if you work on a collaborative project with you know, 20, 30 people working on the same project, it'll be important to include your ID in there. If it's just you, that may not be necessary. Next slide, please. Okay, so Susie, I don't know if you wanted me to keep going here, or but I hope that we managed to to convince you about the importance of reproducibility in research, and that we helped you understand what reproducibility versus replicability, generalizability, how all of those terms relate to each other and what they mean. That we helped you understand all of the different elements that can affect reproducibility, and that we helped give you some tips about how you can improve your record keeping and data management. So I think we actually did it. We managed to stay on time with some time for questions even.
Yay, us!
Yeah. Yeah, that's really good. Thank you very much. And I think every one of us could relate to all of the issues that you've just mentioned. And yeah, thank you very much. So I think now we could give the floor, because we have 10 more minutes. So if anyone has a question or a comment, or maybe they would like to share an experience with us, then please feel free to raise your hand and unmute. Hi. So maybe as people are preparing their questions, I would like to share something. Is one of the important things is that I found the hard way is to keep your data as much as you can on a cloud format. Try to avoid just keeping them in one place, because, for example, my country, Sudan, has been in a war, and we had to flee and left a lot of computers behind and stuff. So then we learned the hard way, then, oh, maybe we should have uploaded things to a cloud, then you could have access to it wherever you are. Okay, we have Jahia. You can unmute. I hope I pronounced the name right. It's Jahia, right? You have your hand raised.
Yes. It's
Yeah.
it's like a nickname. That's not the name actually. My name is Emmy.
Okay. Nice to have you. So please
pardon
go
me
ahead.
for the name confusion.
No worries.
Good afternoon or good day. I'm from Nigeria. My name is Emmy Owichokadoen. And I'm quite excited with the two guest speakers. And it was quite enlightening. However, my question is, when you're making explanation of reproducibility, you're giving more of example of applied sciences. In the case where you are from the humanity or social sciences, how can you give me a quick explanation of how you can apply this reproducibility in your areas of research and data management? That's my question.
So you're from humanities, did I understand that correctly?
Correct.
So social sciences, yeah.
Yeah.
But you work with questionnaires and you interview people, and you do statistics?
Yes. Yeah.
I just know, so I'm not in the humanities myself, but I know that my colleagues from the psychology department who also do interviews and behavioral studies and do statistics and all that, what they do is to ensure reproducibility now, specifically for questionnaires. They try to do these kind of deposition of protocols on how they are going to question people. So there are some standards of how to develop questionnaires, which are good questionnaires for people, so that you reduce any kind of biases. And so I think there are some guidelines probably how to do that, which are also maybe useful for humanities, that people from psychology or maybe in that kind of area came to develop. So that's something that I would probably look into. And so when you follow these kind of basically standards of how to develop good questionnaires, that's also going to improve reproducibility, hopefully, because when you publish your research, so the outcome of your interviews with people, and you follow these kind of guiding principles on how to develop that kind of questionnaire in the first place, so it's standardized, other people could take a similar approach, use the same kind of questions to their own cohort, and then see if they can, in their population that they are going to question, if they can then have the same kind of results. So that would be something that would be good for reproducibility, to have a standard way of creating these interviews. So that's something that comes to my mind. The second thing, data management, of course, that's something that affects you as well, right? You have to read a lot. You have
Correct.
to manage your resources. So if you are able then to have a good kind of data management for all the resources, all the files, all the documents you need to do, so that
Yeah.
data management for yourself, that's really the kind of the first starting point also to teach other people how to do good data management, or to collaborate with others, and try to say, hey, let's all name our files like this. We start with the date, like 2024, April 9th. And then this is like that's going to be the name of the file. And then when you kind of exchange stuff with other people, then you know exactly what is in what file. So again, that's also going to make your life easier, because then you,
Easier. Yeah.
And
So
and
these are-
maybe
And also when it
some
comes to, okay,
yeah, I know
go ahead.
I was
Go ahead.
gonna
Go
add
ahead.
another suggestion for
Yes, I'm listening, Prof.
for those surveys that you are running. It's also
Yeah.
you know, it depends on how you run them. But you have to also think through how you will actually record the responses and how you will code those responses. So if you can harmonize that with others in the group, or in the field, it'll make your data more reproducible. So if you think about, you know, for instance, for the research I'm doing, we also have an element where we have surveys for patients in this case. And so there's a platform called RedCat where we are collecting our responses, but we're part of a larger collective. And so for us to, you know, we could code how we are collecting those responses our own way, but then it becomes harder for anybody else to look at that file and look at whether the responses our patients gave actually are corresponding to what their patients answered. So if you are part of a larger group, or you know, if there are some standards in the fields, it really helps to make sure that you are adhering to those. If they're not, maybe it's the time to create one and start collaborating with others. But those are elements that you can implement to try and increase the transparency and in the long term the reproducibility of that type of survey. Does that help?
Thank you. Yeah, it does.
I see Ahmed also has his hand raised.
Yes, hello. I hope you can all hear me.
Yes.
I am Ahmed Unsur, a psychologist and data scientist from Somalia. I wanted to share one experience about the reproducibility crisis in psychology. During my graduate studies, while I was doing my master's thesis, I have heard about the reproducibility crisis in psychological research. I have also, and in that time, started to write a review paper, which was then published or shared in a repository as a preprint, and then published as a full peer-reviewed paper about the statistical inference issues, things like Dr. Susann mentioned it about the Harkin and Jerry Beacon results, and also what that comes with is the reproducibility crisis in general. one of the things that I found, one of the papers that I found in that time was a paper published in 2015 by the Open Science Collaboration Team, where they replicated 100 scientific studies, studies, including experimental studies and correlation studies, but they were able to succeed only 39%. So that says something. And also regarding the data management, the importance of data management, now being an active participant in data science and machine learning projects, I've also learned the hard way the importance of proper documentation and version control. Yeah, I think with the advancements in technology, there is now a lot of ways to make yourself, in a sense, avoid the headache that comes with not doing the things from the start or from the beginning the proper way. And I really thank you, and thanks also goes to the R&D team for providing these training programs and opportunities. Thank you.
Yeah, thank you for sharing. That's very nice.
Yeah,
I mean, not nice. I'm very. It's they're for none of us. They're great experiences to have when you run into that irreproducible wall. It comes with a lot of frustration and waste of time and waste of resources. But yes, there are a lot of things that you can do to try and avoid it. It just takes a little bit of effort, but it makes your life a bit easier down the road. I think we are at time. Sorry,
Yeah.
Susie, go ahead.
No, I just say that the new generation of people will do things. Of course, that's the way nature works anyway. And now with the connectivity, the internet, where we can all meet, although we would never physically be able to meet because the distance is also long, so we can all learn from each other. And it's a very empowering thing, I think, I also always learn these workshops from everyone attending. So, and from my students all the time. They are younger, they do things differently. So it's, yeah, I have very high hopes for the future that these kind of concepts are going to really penetrate into scientific fields everywhere.
We have one more hand raised. I'm sorry to take some of more time. So would you be willing to stay, Susann and Nele, for just one more question?
Yeah, so I have like 15 more minutes left, so I can do 15.
Okay, perfect. Okay, Amino, you can go ahead and
Thank
unmute.
you. Yeah, good day. Thank you for the great presentations. I'm Amino from Nigeria. I just want to ask, how do we get a cloud storage? That's my question.
Okay, so cloud storage, I think it depends on what you have access to. If you are able to use Google as a cloud storage, or that's also depending on what your country, I'm not sure where you are employed. Some institutions, like my institution, doesn't want us to do anything on Google or Google Docs because the servers for that are sitting in the US. And we have an issue with data protection here in Germany with stuff that's posted in the US. So I'm not sure if your institution where you are employed is restricting you for cloud storage. Ideally, your institution provides cloud storage for you as a researcher, because that would be one of the jobs to provide you with the infrastructure. So maybe you can, if you're not sure yet, maybe you can find out if they do these kind of things, if they host a server where you could have some cloud storage they can use. Because the university or institution should have, of course, interest in keeping the data that you produce for them with them, right? So this is how I know it from a lot of institutions in my country or from other institutions. But yeah, I'm from the global north, so that's like what people usually do. If your institution does not provide cloud storage, you could try to find a trustworthy source, maybe with, I'm not sure if it would make sense maybe to look in your own country if there are servers for people who kind of provide that kind of service. Ideally, it would be a provider where you have to pay a little bit of money, but you always have access to what you have. And it's not a free storage, but they could do whatever they want if they wanted to with your data. So that's sometimes a concern when you deposit stuff. For example, there are the Amazon servers, Google servers, and these kind of companies who are private companies where it's the question if you still own the data then, or if they do something with your data. So that's hard for me to answer from where I'm sitting, but yeah, maybe try first for your own institution, ask them if they provide that, and they should, because you are employed and they should provide the infrastructure. That would be my kind of idea here. We have another.
I just wanted to say that I think the like the norm in Africa is, I think for most African countries, that institutions don't really provide that. I think you have to do it on an individual base. Like it's your data, you're worked hard to get it. So then you sort of, even if it's you have to pay a bit more, then this is usually what happens. But yeah, we have another hand, Bakari. Yeah.
Good afternoon. Good day to everyone. I'm Bakari from the Gambia. Interesting discussions going on. Let me, just like you said, the situation that Aminu is in, most African countries are also finding themselves in that individually you have to be responsible. But I have maneuvered through such situation. In the institution that I worked before, we're using the Google app, education app Shoot, which is free. All your IT needed to do is basically to liaise with Google education app team.
I don't think the people are going.
Tell them that you from Africa and you are from an educational or research setting, that you need that app. So once they verify, they will give you a domain, and then you can register, and then you can use all the apps that are involved, even including Google Drive. Yeah, but you have to liaise with your IT department and let them explore that opportunity. So for me, that's what I did, and it worked. And then we are able to get our email system. Through that, we're able to use Google Doc and all these apps that are involved in even Google Classroom, free of charge. So maybe your IT, liaise with your IT, and the IT can liaise with Google team about the education app Shoot. Possibly that's a way out. Thank you.
Yes, thank you very much. That's also what I would have suggested, to really kind of get on the nerves of your department, because they have to provide that infrastructure. It's too much for researchers in my from my point of view, to also put the responsibility of keeping your own data safe also to you when you have so much other stuff to do. When some colleagues that I know also have to use part of their salary for their own research. So that should not be, I know that's not the world we live in, but you should really try to, if you can, put some pressure on them that they do that. Because they employ you and they want to also have the kind of benefit of you publishing for them, working for them. So they should provide the infrastructure. That's ideally how it is, really. Or it should be like this in the long term. So that's, yeah, thank you for that.
Thank you, Susan. I think we have a question in the chat from Modester. She says qualitative research is highly sensitive to context, including the specific characteristics of participants, setting, and time. The sensitivity can make it challenging to replicate studies in ways that yield identical findings. How can we deal with it?
Yeah, I tried to answer in the chat. So there are really different ways when it comes to patient data, for instance, which tends to be the sensitive data for most researchers. There are different ways to de-identify that. And obviously you have to remove the name and give the person a unique identifier. But then there are different ways, things that maybe you wouldn't consider up front. But if this is a patient visit, you could, for instance, figure out if you know where the person went, to which clinic they went and which dates they came, you could still in some way figure out who the participant was. So there are different rules and regulations on how to de-identify that. One example I gave there is for instance, if you have a longitudinal study where you're following up, whether it's surveys or clinical at different times, you could calculate the first visit or the first survey to be on January 1st of this year, for instance, and recalculate the follow-up visits to those same intervals, so that all patients start on January 1st and nobody can figure out who went where for what.
Yeah, thank you very much, Nele. Ahmed, I can see your hand is raised.
Yes. I just wanted to add one comment about using the cloud services, especially when dealing with sensitive data. One thing that I have heard about a lot in the recent months is with the advent of artificial intelligence and large language models, these systems need a lot of data so in order to train them. So there are some ethical and legal issues, and that some companies and some service providers that they use data of users without telling them in order to train these models. So, and I believe I also agree with Susann, but they said that it's very important to first talk with the local institution whether there are available infrastructures. And yes, I agree also with Lamis that in Africa there are not that in advanced tools, or sometimes they are even not there. But I think it's very important to think about the type of the data and the level of this sensitivity when one tries to store it in the free and public cloud storages. Some of them nowadays, they have paid services with specific policies and agreements, but yeah, I just wanted to add that. And that also with these modern tools, that also creates another issues and another problems that we need to think about very carefully when using these cloud services. Thank you.
Yeah, I agree 100%, and that's life. Like, we get tools that help us, but then they also have some downsides that we have to deal with and figure out along the way. So I think just to be mindful of everyone's time, especially Susann and Nele, we would like to thank you very much for today's session. It was very informative and very eye-opening, really, for all of us. And we really look forward for the next session, which is going to be next week, and to see how things would build up on this session. So thank you, everyone, for joining, and hope to see you next week for session 2.
Yes,
Bye.
Thank you.
for your
Thank you. Bye.
Thank you.
Thank you everyone for joining.
Thank you.
Bye.